this course, there's two types of inference problems that we're going to consider. We're going to have our estimation problems and our hypothesis test problems. So in Chapter 9, we learned how those estimation problems can be answered when dealing with population proportions using confidence intervals. In Chapter 10, we're going to see how sample data can be used to help us decide whether some claim or some hypothesis about a population proportion is believable. So I want us to start with an article from Life Science, and the question, it was in 2005, and it was based on a study published in Fertility and Sterility that was summarized in this Life Science article. So the article made these statements. When given the opportunity to choose the sex of their baby, women are just as likely to choose pink socks as blue, a new study shows. Now, we've already had the discussion about how boy and girl doesn't necessarily have to be pink and blue, but the idea here is that women are just as likely to choose boys as girls, or as girls as boys, from the study. So how did they make that determination? Well, there were 561 women who participated in this study. 229 said that they would like to choose the sex of a future child. Then among those 229, there was not a greater demand for boys or girls. So we can translate that by looking at this statement being equivalent to the claim that the proportion of women who would choose a girl is 0.50 or 50%. So there's some additional information that we need to have about this study. So this study was based on a survey with 19 questions that was mailed to 1,385 women who had visited the Center for Reproductive Medicine at Brigham and Women's Hospital. So out of those 1,385, only 561 returned the survey. Now, from those 561, only 229, or about 40.8%, even wanted to select the sex of their baby. Now, of those 229, we saw that 89, which was about 38.9, wanted a boy, and 140, which is about 61.1, wanted a girl. Now, I want you to look at those numbers, because that study, or the results that was published in this article, stated that women were not more likely to choose one gender or one sex over the other. So how is it that these different numbers can have a conclusion that it's 50-50? Well, let's take a look closer at what's going on. How do we know that this is truly no preference? So even when the population proportion who would choose a girl is 50%, so if we make that assumption that it's equally spread, the sample proportion certainly would be different from 50%. We know enough about sampling variability now to understand that it would be rare for us to get exactly 50%. So that 0.611 isn't really far enough away to be just due to sampling variability. So when the population proportion of who would choose a girl is 0.5, observing a sample as large as 0.611 might be very unlikely. So how would we know? Well, we're going to learn some techniques in this chapter to identify how likely a particular sample value would be. And so if it was unlikely to obtain 0.611, then that would provide evidence against the claim that the population proportion is 0.5. So basically the big idea here is if something happens, if we assume a particular value for the population proportion, we gather a sample and we get the sample proportion. We determine, based on that sampling distribution, how likely it is to obtain that sample value. If it's not very unlikely, or another way of saying that is if it's relatively likely to have obtained that sample value, then we don't have any evidence to go against what we assumed for our population proportion. Now, if the probability of obtaining a sample statistic was unlikely, then we would have evidence against our claim or against that proportion that we decided was possibly true for our proportion. So we're going to be looking at this idea in Chapter 10, How do we set up these hypothesis tests? How do we determine if something's likely or unlikely? And then look at some potential calls for mistakes and errors that could be happening in these studies.